is working with radicals. So we're almost done with that. And we need to learn how to do some equations, and we'll get into some complex numbers a little bit in here. Okay, so let me get this on here. Okay, so to start with, okay, since we've been talking about radicals, we're kind of looking at how you would solve equations that might have radicals involved in it. Usually what I like to start students off by is just giving something that's simple enough that you could do in your head. Okay, that's the idea. So let me just have you think about that just for a second here. Now remember, what you're doing is you're putting a number in there, you're adding 1 to it, then when you do the square root, you get 3's. So what do you think? What'd you say? 8. Let's see if she's right. What's 8 plus 1? 9. What's the square root of 9? So she's right. There are times, of course, when you can do things in your head, right? Okay, most of the time you can't do it in your head. So that's why we have to learn procedural things to get that worked out. So yeah, without a doubt, the answer is 8. Now I'm going to go ahead. You know that I'm real big into having you guys check answers, but before I teach you how to solve this, the methodology for that, let's just verify that that's right. So what do you do when you check an equation? What do you do with that 8? Plug it back in, right, for x. Okay, so let's go ahead and do that. So where you see an x, put an 8. You'll have 8 plus 1, so that's square root of 9, and we know that's equal to 3, okay? Do you think there's anything else that would work? The only number that I can think of that I add 1 to get 9 is an 8. Anything else? Yeah, that's probably it. Okay, there's going to be times when we might get more than one answer then. Okay, so what we generally do, and we're going to start kind of simple here, is I've kind of written out basically what you do here. And then we'll kind of talk about why you do this as we go through things. So we usually want to isolate a radical. This doesn't apply to this problem, but for instance, if you had something like x plus 1 minus 2 equals 3, that radical is not isolated. You know what I mean by that? That means that 2, we wouldn't want that 2 there. Now it's isolated. What does that mean? There's nothing outside of that radical, okay? That's something you're going to do. We did that back when we did absolute value, back when I was teaching that at the beginning of the semester. Remember I said, what do you do first? Isolate. Okay, so that's going to be a big deal here. Okay, then what we're going to do is we raise both sides to a necessary power. So I'm going to talk about why that is, okay, just a minute. So let's say that we had something, let's say you had something like this. X, square root of x is equal to 5. Now that's one that I hope everybody could go boom, boom, and tell me what the answer is. What's the answer? 25, right. Okay, all right, good. Now what we do is, since that's a second root, we undo that operation by doing this. We square both sides. And like we've learned all semester, if you're solving an equation, what you do to one side, you've got to do the same operation the other side. Now, let's think about why this makes sense, because we have learned this. That is really the square root of x squared. How many times last class did I ask you, what's the square root of something squared? Like 1,000,000 times. What is the square root of something squared? Itself, exactly. Okay? So see, what that does is that undoes that operation. That's the idea. Okay? What if you had something like this? Okay, what if you had cube root of x equals 2? You know what the answer is? 8. Okay, what's the cube root of 8? 2. Okay, so what you would do on this is you would raise both sides to the third power. Okay, now you want to understand the y part of this so that you'll remember this. So we have certainly talked about this. If you do the cube root of something to the third, what do you get? Itself, exactly. Okay, so if you did that, see, this would give you 8. And then when you do that cube root right there, that undoes that and that gives x equals 8. So that's the idea. So what if you had a fourth root? How do you make a fourth root go away? Probably raise it to the fourth power, don't you think? Okay, that's the procedure, okay? So that's the idea, and once you get rid of that radical, then you're going to solve the equation, which will be something that you've done before, and then you want to check the answers. There are times when your answer doesn't work, even though algebraically you've done everything correct, not a single mistake. You'll find if you plug it back in, it doesn't work. That's called extraneous, okay? We'll kind of get to that as we go through that. Okay, so let's now run through some stuff. and show you kind of what we're going to be working on here then. Okay, here's what you kind of go through as a procedure. If you look at problem number 2, would you consider that radical to be isolated?
Yes.
Yes, okay, so there's nothing we need to do. So that means step 1, we're kind of done with that. Step 2, what do you need to do to make that radical go away now, since it's a square root? You square both sides, right? Okay, second root, square both sides. So what I'm going to do here is I'm going to have you do this, then have you do that, okay? Now, when you square the square root, what happens? It comes off, okay, so that's x plus 1, and then 3 to the seconds equal 9. Now, see, now that you have your radical off, it's easy to do. So how do you get rid of that 1? Subtract it, good. Okay, so you're going to subtract 1 from both sides, like this. And then that's going to give x is equal to 8. That's the answer that some of you told me was the answer in your head. Okay? The reason we do a procedure is we need to know kind of what's going on in the problem. Okay? If you can't do it in your head, you have to use a procedure to get you there. Okay? Okay, let's go through this next one. This one you got to be really careful about. So would you consider the radical isolated, yes or no?
Yes.
That's a yes, okay? Always check for that though. Okay, now, how do you make the radical go away since it's a square root? Square both sides, okay? Remember, the square root of something to the second is itself. So if we do this, I'm going to square both sides. Notice I'm squaring that whole entire -4. That's why I'm putting that in parentheses, okay? Then the radical goes off because the square root of something squared is itself. And then that's going to be -4 times -4 is 16, right? Okay? Now, simple equation. What do you do to both sides? Yeah, divide by 6. Good. So you go ahead and divide by 6. Okay? Then when you do that, you're going to end up with x equals 16 over 6. What if you put 16 over 6 in my math lab? Right or wrong? You get the big sorry. What do you need to do? Yeah, you got to reduce the fraction. Okay, so we're used to that by now. So let's do that. So you can divide by 2 if you want to, and that would give 8 over 3. Okay, it appears the answer of this problem is 8 over 3. Now, one of the things that you have to do as a student is a lot of times, and I'm really big, have been all semester in getting you guys to check stuff, because to me, that's how you understand stuff well. That's part of it, is, okay, I got an answer, why is this an answer? Okay, that's how you really gain the understanding I want you to have. So what we're going to do is check the answer. So go ahead and write down the problem. It's 6 times something is equal to -4. Okay, like that. Now what I'm going to do is I'm going to plug in that 8/3. Then we're going to see what happens when we check this out. And don't panic when you see fractions. Don't use decimals. Okay, decimals are more work than fractions are. So I'm just going to have 6 over 1 times 8 over 3 like that. Okay, we've done fractions all semester. You multiply straight across. And if you did, you would have 24 over 3, right? Not 24. Let's try that again. 6 times 8 is what, class? 48, okay? All right, so that's 48 over 3. And you could also reduce the 6 and 3 first, so that gives 16, all right? But what's the square root of 16? That's a 4, okay? It's not -4. And whenever you're doing, the only time that we looked at so far in this class when we had a negative answer to a square root would be like if we had something like that. Remember, we looked at that a little bit. Okay, if you have that, that's telling us we have a negative answer. But if you have just that, that's really asking for the positive answer to that. Okay, like that. So see, this does not check. The 4 is not equal to -4, so that means the -4 can't, the 8/3 cannot be the right answer to the problem. Does that make sense? See, it didn't check, but I did nothing wrong, and that can happen. Okay, we call that an extraneous solution. So what we would get on this one is the answer of this problem is no solution. We actually say it's no real solution when we do that. We hadn't even talked about complex numbers yet, so don't worry about that yet. So there's no real solution to that, okay? Now, I want to show you something on this. When I was doing this problem, I already knew the answer was no solution. I want to show you why I knew that and see if this makes any sense to you. So when I see an equation that looks like this, square root of something equals negative number, I already know that it's no solution. Does anybody know why?
You can't square a negative number.
Well, you can square a negative number.
You can't square into a negative number.
All right.
Let me say that again.
What's that?
It's two positives, yeah.
Yeah, okay. When you're doing a square root, if you do a square root and there's nothing in front, doesn't that always give you a positive answer?
Yes.
Okay? So that's the idea. You can't do that. See, if I see a problem like that, now the key thing is that's got to be isolated. There can't be anything outside of that. But if I saw that that was equal to -1, I would know automatically there's no answer. Doesn't make any sense. Okay? So that's something you want to think about a little bit, and it can save you a little bit of work. Okay? Because the other choice is just solve it, check it, and you'll see that it's extraneous. It does not work. Okay? Does that make sense to everybody? Okay? So if you have a square root equals a positive number in your equation, and that square root's isolated, you should be able to generate an answer to that. Yes? Go ahead. I can't hear you because you're way back there.
Test, do you care if we just write no solution? Or do we
No, I'm okay. If you saw that, I would want a student to be able to notice that. Okay? I would also want you to be able, if you didn't see that, to show that it has no solution. So that's one of the things I want you to be able to observe in these problems, see? Okay? All right? All right, does that make sense to everybody? Okay? So what if I gave you this problem right here on a test? Okay, like she's saying. What if I gave x plus 1 equals -12? What's the answer? Okay, yeah, same thing. But you got to be careful. What if I did this? And I always see students fall for this. A lot of times I'll do something like, I'll say like square root of x minus 4 equals -1. Students just say, no solution. Teacher gave me an easy problem. No. Okay, here's why. Because in this problem, the first step you have to do is you have to isolate. And when you do that, you have square root of x equals 3. Now it has an answer, doesn't it? So you got to understand it real clearly, see? Okay, you got to be careful about that. Okay, so let's go on and I'm going to go ahead and do this number 4, then I'm going to give you time to work on a few problems, and I'll walk around and see if you're on the right track. Okay, so if you look at number 4, is that radical all by itself? Is it isolated? No. So what do? Add 8. Good. Add 8 to both sides. Okay, so we want to do that. Okay, and then that's going to give you square root of 2x plus 2 now is equal to 8. Okay, now how do you make the radical go away? Square it. Okay, that's good. So we want to do that. Okay, once you get past this point, it'll be a piece of cake. Okay, that's 2x plus 2. We're doing a square root of something squared, so it's itself, like we've been talking. That's equal to 64. Then from there, you'll have no problem finishing it up, I think, by now. Okay, so subtract 2. That'll give 2x equals 62. Then you can divide by 2. So that will give x equals 31. Okay, like that. Okay? Now let's go ahead and find out if it's right. Now remember, we've talked about this all semester. If you check, where do you go? Well, way back to the beginning. Don't go to any step in the problem. Go to the very beginning. So let's go ahead and just verify this is right. There are times when you can do these in your head too. So we have 2 times something plus 2 under a radical minus 8 is 0. So we're just going to plug in that 31. Okay, if you work what's under the radical, what would be 2 times 31 plus 2? That's 62 plus 2. So that's 64. Can you tell it's right now? Yeah, okay, because 8 minus 8. Okay, so we know we're right, 100%. Okay, we're good. All right? Okay, any questions so far? Okay, so I'm going to let you go to just the next 2 problems. We're going to kind of build up the level we do on this. We're going to kind of start with this. So let's do these 2. Also check. When I come around and look at your paper, I want to see it you check. Don't be lazy about that. Do it. Where will I sign my attendance today? Okay, where do I got it? Yeah, there's always somebody. Okay, I'll walk around just kind of see if you're on the right track with what you're doing, and then be sure you check and verify. If you get a fraction answer, don't worry about it. Okay, it's not hard to check a fraction. It usually works its way out of the problem anyway. Okay, that's good. So you checked it, you verified it, that's good. Okay, that's good. Yeah, that one you want to be a little careful about. But, except you have to square the 3.
Oh.
There you go. Now you wrote it on your paper, you just forgot to do it. Okay. Doing okay. All right. Good observation. Okay. Okay. So once you have that isolated, you know, you go further if you want to, but you don't have to. That's good. Okay, well, you see, after you isolate that, you would have, you would end up having this. So right now, you know that can't happen, right? You can go on further. If you go on further, you'll get an answer, but that answer won't check. So you go stop. You really understand it. Right? Be careful about that, though. Okay, I'm going to go and check it. Okay, so we got 9 over 2. That looks good. Okay, that's good. Well, you can move on to that 7 if you want to. The only difference is it's a third root, so once you kind of establish the general idea, then it's all going to be the same. All right. Now that right there, so you can out the square root of 3. You wrote that on there, but you didn't ever do it, right? All right, that looks good. You caught that, so that's fine. Okay, you're okay. What do you got there? That's 2. 2.
Wasn't that right for you? Oops.
No, you're okay.
I've been doing that for some reason today.
Well, I do that sometimes too. You're fine. And I guess you saw that.
Yeah.
Yeah, that's good. Okay, good observation. Okay, let's run through this. Let's make sure we're doing these okay. I want to see if you guys caught a few things here. Some of you did, some of you didn't. Okay, so the idea is question number 1 always, is this isolated? Okay, I'm going to keep stressing that because that's where students mess up on these problems all the time. So you square both sides. It is isolated. Okay, so what you would get is 2x is equal to 9. Then you divide both sides by 2. So you would end up with x is equal to 9 over 2. Okay? I didn't see it. The only problem I saw is some of you forgot to square the 3. You wrote it on your paper, but you forgot to square it. Okay, when you check, I'd want you to go back to the original and plug in the 9/2. A lot of times students want to go decimals. Why would you want to go decimals? What happens to the 2's anyway? They cancel. I'll tell you, most of the time when you get a fraction answer, it works its way out of the problem anyway. Not always, but often. So what you end up with is square root of 9 equals 3. That's right, isn't it? That's all you got right. Okay? All right. I think most of you actually noticed what I was looking for on this problem is you have to isolate it, right? So what did you do first on this problem? You subtract 8. Good. You have to do that. I didn't see anybody forget to do that. That's good. So now I have this. Okay. What could you conclude now? Okay, so a lot of you did that, right? You saw what I wanted you to see. Some of you went on and worked it out, but your answer wouldn't check. Okay, remember, if you have a square root that's all isolated equals a negative number, you're not going to get anything out of that. Your answer isn't going to check. So you could immediately go through and just put no solution. Okay? Or, how many people worked it out? I'm just curious. Several of you did. Okay. Did you check it? You didn't check it. Okay, so if you didn't do that on a test or something, you'd lose some points because it doesn't check. So you got to do that. Okay? All right, let's go on down to number 7. Now the problems are just going to advance a little bit, but it's the same idea. When we're looking at number 7, you have a cube root now. Okay, so question number 1. Tell me if this is isolated. No. So what do? Add 2. Okay? All right, so I think we're getting that under control. Just don't forget it. Okay, so we have cube root of x plus 1 is equal to 2. Now, how do you make a cube root go away? Third power. Okay, you got to understand the y part of this. See, technically, if you cube that side, then you would have x plus 1 to the third. Okay, and what's the third root of something to the third? Itself. Okay, that's what we've been talking about, so that's the idea. Okay, so this time we're going to raise both sides to the third power, so be sure that you're aware of that. That's going to be x plus 1, and that's going to be 8 like that. Okay, what's the answer? Apparent answer. 7. Okay, right. So you can subtract 1 from both sides. You can do that in your head if you want to. If you get down to that point and you can do that in your head, that's fine. So let's find out if that's right. Okay? Let's see if you can do this in your head, by the way. A lot of times I like to tell students, try to see if you can check in your head. Okay, let's do that. So what's 7 plus 1? 8. What's the cube root of 8? 2. What's 2 minus 2?
0.
So you see how easy it is, like you're doing a test or something? That took like 5 seconds. Boom, boom, we tell we're right, okay? You can do that, okay? And that's how you really gain, to me, a better understanding of this stuff anyway, is solve, check, solve, check. Understand the y part. Okay, well, if you did that, again, we're just doing 7 plus 1 minus 2 equals 0. And like we were doing in our head, that's going to work out, isn't it? Okay? 2 minus 2 is 0. Okay? Once you get to a point where you can see that in your head, then that's good enough. Okay. Now, let's look at number 8, and this will have a little bit different twist to it. The methodology is the same. So, question number 1 is that radical isolated? Yes. So, it's a square root. What do you do to both sides? Square both sides. Okay? Right. So, what we're going to go ahead and do is we have 6x minus 29 equals 6 minus x, and then we're going to square both sides. Okay, so you got to have, this particular problem is going to have a lot of things that we've done in the past, and it's got a lot more working on in it, okay? Okay, what's the left side?
6x.
Radical comes off. What do you do at the right side? Foil, okay, kind of multiply it out, okay? You know, and here's something I want you guys to pay attention to. In this level of a class, I've generally showed you, if you have that situation, like a binomial square, just write it out twice and you can do the distributive property or the FOIL. But don't do this. God, I see students do this all the time. Doesn't even matter what level of class I teach. There's a tendency to want to say, well, that's 36. That's a positive x squared. Okay, don't do that. Don't fall for that. You've got to write out those steps when you do that. Usually when I teach this level of a class, I don't spend a lot of time on the shortcut. We've talked about that, but just go ahead and just multiply that out, okay? And then you're going to have that middle term, so be careful about that. So go ahead and start multiplying that out and do that, because you guys have done a lot of the FOIL. We've been doing a lot of that lately. So the first term is 36, okay? Outside term is minus 6x. Inside term's the same. And if you square a binomial, that'll always happen. That inner and outer will be the same. And then the last term is positive x squared, right? Okay. Now, what could you do to the right side? What do you see? Like terms? Okay, right? Okay, put them together. Okay, that's what I do. Okay, keep it all simple. Those things go together. That's going to be negative 6 minus 6 is negative 12x plus x squared like that. Okay, let's pause there. Do you guys got any questions about what I've done so far? Okay, what I see is a power. I see x to the second. Do you remember what that tells you to do in your equation solving? One side equals 0. Okay, what else? I haven't done this in a long time. Factoring. This has factoring in it, okay? So the idea on this, you couldn't just get the x's by itself on a side. Once you have a power, like a second or third power or higher, typically you think about factoring, like we've done. So what we're going to do is make one side equal 0. To me, it's just as easy to make the left side equal as 0 because it has less stuff on it. So you can just move things if you want to. Remember, I've shown you, you're subtracting 6x from both sides, so you can do that, or you can just move it and make it a negative 6x. Same thing with minus 29. Add 29, or you can move it, okay? To me, the higher you get in math, the more you want to be able to just kind of rearrange things. And we've done a lot of that this semester. So what you would have is you would have 0 equals, then I'm going to write this as just 36 minus 12x plus x squared minus 6x, and then plus 29 like that. Okay, then I got like terms to put together, so put them together. Okay, so if I do that, I'm going to put the x squared first. That's the order we like it in when we're factoring. Negative 12 minus 6 is negative 18x, okay? And then the next number on that is, let's see, what's that, 65? Right? Okay, okay, I'm just making sure, okay? All right. Okay, now we're going to try to factor this and see. Well, 65 ends in 5. So what does that mean it divides by? By 5, okay? Now you could take a calculator if you needed to, but 5 times 13 is going to be 65, okay? So we're going to go ahead and we're going to draw 2 parentheses like we've been doing. First term's x and x, okay? Is 13 and 5 a good combination? Yes, how come? You can make it add that middle term, right? So what we have is you have 5 and 13, and then you're going to have 2 minus signs, because that middle term is, the inner is 5x, the outer is 13x, so you're trying to make that combine to negative 18x, so you would have that, okay? So we got that. Does that look familiar to everybody? Okay, I hope so, okay? All right. Now, we have 2 potential answers to this problem, and you can do this in your head. But back when we were doing this, I told you you could do this in your head. You just set each factor equal to 0. So what would be the 2 potential answers?
13.
Right, 5 and 13. Okay, good. Okay, now I stress potential, okay? So what that means is, remember, when you're doing a radical equation, don't give up when you get an answer. Find out if you're right, okay? So let's find that out. We're going to go ahead and check this kind of at the side. So when we check it, we want to go all the way back to the original equation, and you want to plug in each answer just one at a time. So let's work with the x equals 5. So if you go back to the original equation, you would have square root of 6 times 5 minus 29, and then you're going to see if that's equal to 6 minus 5. If it is, it's an answer. If it doesn't work, it's not an answer, okay? What do you think? That would be 30 minus 29. That's 1, right? 6 minus 5 is 1. Is that good enough? Yeah, okay. So that one's good. Okay, we know that one's right. Okay, let's try the next one. Okay, so let's work with x equals 13. So if we do that, we're going to have 6 times 13 minus 29, and we'll see if that's equal to 6 minus 13. Now let me show you something on this. I'm going to go ahead and work it out, but I want to see how many people spot this. If you went ahead and did this, I think that is 78 minus 29, if you do that. Okay, then I think that is 49. Okay, what's the square root of 49? 7. But this is 6 minus 7, that's negative 7. Okay, so the thing is, those things are not equal. Okay, that thing is not equal to negative 7. So what would happen is that one would have to be thrown out. Okay, we're trying to see that this is equal to 6 minus 13 or negative 7. Does everybody follow that? Okay, so see how they're off by that negative? That happens all the time on this. And one thing I was going to show you on this too is, as a student, if you want to save a little bit of time, you could actually do this. I know this is a square root of something, but that's going to be negative 7. Can that happen? No. Okay, so you can stop there and say, okay, forget that one. Okay, so the only answer to the problem is x equals 5. Okay, so what we say is that 13 was an extraneous solution. Okay, you do a lot in higher math too when you're solving equations. You may be doing everything correct, but then then it doesn't check. Okay, everybody follow me on that? Okay. Okay, so I'm gonna let you do a few problems.
There's only one answer to that one?
Yeah, just one answer. It's x equals 5. Okay. Sometimes you have no answer. If you have a second power, you could have potentially no answer, one answer, or even 2 answers. It all just sort of depends. Okay, so I'm going to give you guys a little time to work on the next 3 and see how that goes. Okay. And you can compare answers a little bit like you're used to doing and see if you're on the right track, but you have the ability to tell you're right. So please do that. isolated.
Lovely, I'm doing fine. Yeah,
That's great. Yeah, you're going to work on the cube roots.
Yeah.
Let's check it out, see if it works, huh? Okay, you isolated. It works. Did that work okay? That worked it. Okay. That looks good. That looks good. That looks good. Okay, so you're going to face it apart. Yeah. Okay. No, not in the checking. When you're checking, you worked it out. So you've got what I think's a good answer. And what you're forgetting about that is you're doing 3 times 40. I don't know either. Okay, this kind of stuff I do. That looks good. Okay, so checking out okay? I think one thing that see that 5 is under radical, so that won't become 125, right? So you're doing cube root of 125. That's good. You're on the right track there. Okay, then you got to just kind of start getting one side equals 0. Good. Okay, and then that one. That was the radical isolated. There's nothing else there, right? So then you can do both sides for both sides. Okay. That looks good. Let's see. Actually, the X is crossed out. Yeah, okay. That's good. Good. Well, that one, the X is canceled out. That's it. Yes. Yeah, then you just solve that equation. Now that equation you don't factor, so you have the powers, you can just isolate X by solving the sum. Okay. You should get it. I like you're on the right track. See what I mean? Okay, now what you have, generally if you have powers, exponents, then you gotta get one side equals 0 factor. So you can move everything to one side, you can move everything on that side to that side. And equal 0, and see what happens from there. Okay. Real good. Yeah, now so you're going to find that actually crossed out. So what you still have to isolate the X, so now it's just kind of a standard equation, the X by itself. Unfactor, right? Just add to both sides, right? See what I mean? Oh yeah, you don't factor. See, 7x minus 14, you can take a common factor of 7. Now that won't be able to go. I mean, if you want to, just isolate that X. That looks good. Paper's very colorful. That right there. You got to complete that. Gotta do that. good. Okay, now since there's a second power, you need to get everything on one side you can move. It doesn't matter what side. Once you just move, you can move everything from that side to that side. Okay, and then you'll kind of want to see what's left over on that. One of them, find one of them didn't check. Okay. Yeah, that's right. The way I would kind of look at that is, if you see that when you plug that in, you're going to get a negative number, you know that's impossible. So you can save a little bit of work by doing that then. Okay, keep going. You're almost there. On the right track. So the last problem is the one that has the most work. I just got all the factoring and everything in. Yep, you're good. And see what you can do there is you can collect the like terms there.
Right.
And then everything on one side equals zero. Because what you'll find is when you do that, the X squared is going to cross out, which is okay.
Right.
That makes it even easier. Then you don't have to worry about factoring. Okay.
So if you were to check an answer, commit, sometimes it's not going to work.
Yes.
Like at all.
Yeah, it'll happen.
It's not good.
Yeah, see, you're okay. I think that should be a negative 3, right? Okay, because if you have X plus 3 equals 0, you know. Okay. And then you want to check that one. So I think what you'll find on that last one, I think one of them will work, one of them won't work. And you never know that until you go through the details of the checking. Okay, that's the idea. So we're okay. Okay, see, that's good. Now see that one.
Oh, yeah.
Double check. Double check. There's something going on. Didn't find it. Yeah, we're going to go over this in just a few minutes here. And ready to factor.
So they end up going to get 7.
What are some numbers that multiply to get 12? We'll make 4 and 3 out of -1. There you go. So you need to do the factoring, right? And then set it.
So work it out.
You're almost there. You're almost there. Okay. See, those things cross out. So that would be 0. Those would cross out. So you end up having 0 equals 7x. Then you can solve that equation. Okay. Okay, so let's see. Let's go ahead and do this. Hey, you guys are doing good. There was a couple of little things I noticed on there that I wanted to kind of mention. But for the most part, we're doing good. Nobody had any trouble getting the first one, okay? Because there's no factoring or anything involved in that. So that one, I think you want to add 5 to both sides. I'm going to do this real quick because I think everybody's got this one. So you'd have 3x plus 5 equals 5. And then third power, raise both sides to the third power. So you'd have 3x plus 5 equals 125. Okay, what did you guys get as your answer on this one? Generally, 40. Okay, I think I saw everybody get down to that point. Okay, so that would be 3x is equal to 120. Then you can divide both sides by 3 to get x equals 40. Okay, everybody was solid with that, right? Okay, did everybody check? That one's not too bad, okay? All right, we good with the checking? Okay. All right, we'll spend a little bit more time on the next ones because these are a little bit more work. Okay, if you look at number 10, is the radical isolated, yes or no?
Yes.
Yes, so you're ready to square both sides, okay? You're doing the square root of something squared. That undoes that and gives itself. So that's x squared minus 3x plus 18. Then you got to kind of go to the side of your paper. Now you can bring this down and you can write that out twice and multiply it out, okay, which is what I'm going to do. You can do that on the side of paper too, or you can do it in your head, okay, doesn't matter. So when I do this, I'm going to have x squared minus 3x plus 18. I'm bringing that down. Then make sure you did the FOIL correctly. You're going to have x squared plus 2x plus 4. I didn't see anybody have any issue with that, so I'm going to do that real fast. And then this is x squared minus 3x plus 18 equals x squared plus 4x plus 4. Okay? All right, is everybody good to there? Now this is where you started asking me questions, some of you, okay? So the way I look at this is if I see a power, okay, then the thought process is a little bit different approach. One side equals 0 trying to factor. That's the idea. So you decide which side you want to be 0. It doesn't make any difference. It'll work out the same way either way. So what I'm going to do is I'm just going to leave this side the way it is, and I'm just going to move stuff, okay? I've taught you certainly how to do that. Remember, the sign's going to change, so that's minus x squared, minus 4x, and then minus 4 is equal to 0, okay? You got a bunch of like terms, so put them together. What happened to the x squareds on this problem? Okay, so that means we really don't have to factor anymore, although you could, okay? So now when we put these like terms together, that's going to be negative 7x there, and then 18 minus 4 is going to be plus 14 equals 0. Okay, now some of you got stuck there, okay, because you're thinking factoring. Well, you don't have to factor. What you could do in this problem, there's several ways to do it. You could move the 7x there, okay, so you get 14 equals 7x, so you can do that in your head. What's the answer? 2, okay? We should have got 2. Now, I think most everybody got 2. You might not have done it exactly the way I've done, but that doesn't matter. So you would end up dividing by 7, so you would get x equals 2. Now, that is a potential answer, okay? Because we don't know, so you got to check, okay, whether you like it or not. So let's go ahead and see if that worked. Those of you that checked it, did it work? Yes. Okay, let's see. So I'm going to write this as 2 squared minus 3 times 2 plus 18, and then we're going to see if that's equal to 2 plus 2. Okay? So let's see. This is going to be under the radical. That's going to be 4 minus 6 plus 18. So that's going to be 16. Square root of 16 is 4. Is that 2 plus 2? Mm-hmm. Indeed. So that is the definite answer to the problem. We're done. Okay? Any questions about that? Okay? All right, let's see what we have on this next one here. Okay, is the radical, is that isolated? Yes. Okay, yes, so we want to square both sides. Okay, like this. And get that done. Okay, so just make sure that you've got all the details correct. Now, the left side, the radical comes off, like we've learned. Then you want to write this out twice and multiply that out. Okay? So let's do that. Make sure you did this okay. So this is going to be 13 minus x. We're going to run through and distribute that now. So that's x squared minus 1x. Enter is minus 1x. And then plus 1 like that. Okay? So that's going to give 13 minus x equals x to the second minus 2x plus 1. So let me pause there for a minute and see if you guys got any issues with what I did. Everything I've done in this problem is stuff you've done before, right? FOIL, collect like terms, all that stuff like that. Okay, now why do you want to set one side equal to 0 now? Because you have a power, exactly. See, that's what you get in your head when you solve equations. You got to know which technique applies to what. So I'm going to move everything on the left side to the right side. So I'll have 0 equals x squared minus 2x plus 1 minus 13 plus x. Be sure if you do it that way that you change those signs. So now if we do that, we're going to have 0 equals x squared. These are like terms, so negative 2x plus x is minus x, and 1 minus 13 is minus 12. So if you got down to that point, that's good. Did you get down to that point? Okay, because if you make mistakes, you may end up with something that doesn't factor, and at this stage in the class, you wouldn't know what to do. Okay, so we're going to go through and factor this. Okay, it goes like this. We have x and x. What's the right combination for 12? 4 and 3. How come? 4 and 3 can also be made to add up to negative 1, right? Okay, so we're going to put in a 4 and 3. Okay, and then make sure your signs are right. So that inner is 4x, that outer is 3x. How do you make 4 and 3 add up to negative 1? Negative 4 plus 3, right? Okay. We hadn't done any much factoring in a while here, but we did a lot earlier this semester. Okay, so you have that. Okay, what are the potential answers in your head? 4, what else? Negative 3, okay? So it looks like there's a possibility that we would have x equals 4, x equals negative 3. How many people checked on this? Okay, that's good. Did one of them not work?
Yeah.
Which one didn't work? I think it's the negative 3. I can actually tell it's negative 3, and I'll show you how I know that already. So I'm not going to check the 4, okay, just save a little bit of time. So that one works out okay. Now, if you go through the negative 3, x equals negative 3, you would have 13 minus negative 3, so you got to be careful on that. And then when you check on this right side, you'd have negative 3 minus 1. I already know it's wrong. Does anybody already know it's wrong? How come? It's going to be a negative, exactly. Look at that. Okay, you're going to end up with negative 4. Is that ever going to happen? No, square root is not going to be negative. It's going to be positive, okay? So then you end up with that. That's false, so you throw that out. So the only answer to this problem then is x equals 4, okay? That's it. Okay, so that is what I'm going to show you on radical equations. Now, we're going to go ahead and break now. Okay, so Pythagorean Theorem, let's go over that. So basically all I want you to do on this, a lot of times students remember this from their background, so I'm not going to spend a lot of time on it. So basically, a couple of things you want to know is the two sides that make the right angle are called the legs of the triangle, and then the longest side, that's the one that's opposite the right angle, is called the hypotenuse.
You got it backwards.
What's that? Oh, I've got the wrong thing here going on, don't I? Okay. That's what I meant, okay? All right. Okay. All right. So you want to make a diagram of that, and a lot of times students just, all they know is a squared plus b squared equals c squared, but they don't know what it means. The a and b are the legs. The hypotenuse is the c, that's the longest side of the triangle like that. So first of all, the Pythagorean theorem only works if you have a right triangle. A right triangle means you have a 90-degree angle in it. If it doesn't have a 90-degree angle, then the Pythagorean theorem's useless. So a right angle, of course, is 90 degrees. Okay, so the general way that we do this is we say this is C, and we say the legs are A and B. And it doesn't matter which one's A and which one's B, but the hypotenuse is always C. Okay, so we're just going to do some real simple things with this. The Pythagorean theorem has been around for over 2,000 years, so it's very old. There was even a president of the United States who proved it. Did you know that? And it's nobody recently. Okay, not the current president. As far as I know, he hadn't proved it. You know who it was? Okay, it was actually James Garfield. So it goes back in the 1800s. So I like to throw that out there because I think that's interesting. So this particular problem right here is we're going to call that C. See, that's the hypotenuse. And then these things are A and B. And it doesn't matter which is which. Okay, so you just have, and c squared equals a squared plus b squared. It doesn't matter what side the c's on, but that is by itself in the equation. So you just have c squared equals 15 squared plus 20 squared. And then we're going to work that out. Now, you can use your calculator on this. When you get into next week's test, you will have a little bit of Pythagorean theorem. You'll have your calculator. So if you do 15 to the second, that's 225. If you do 20 to the second, that's 400. Okay? And then what you want to do is go ahead and add those numbers together. So that's going to give 625. Okay? But when we get to this point in the problem, and I see students do this all the time, a lot of times they're not paying attention or they're not thinking. They'll just say 625 is the answer. What in the world? What? Oh, I know what I did. Okay.
No cracks, right?
Try it again. Okay, let's see if we can get it right back on.
Class are just automatically gassed.
Nothing broke, that's the main thing.
What do you don't know?
Awful.
Looks like you should be okay.
I think you physically showered.
It unplugged.
This is what it is, okay? There we go. Now we're back in business. Okay. So, what I was saying on this, I'm going to make sure I don't do that again, is 625 is a tad bit long, don't you think?
Yes.
So what do you got to do on that equation? You're not done. You got to square root both sides. Good. Okay, and see, now that we've learned square roots, then you know that the square root of something squared is itself, right? And then you could go to your calculator, so you do get 25. So that's the answer. So you do have to do the square root at the end of the problem like that. Okay? Okay, the next one is that 4 is supposed to be there. So let's go ahead and let's write down, and it doesn't matter which order, a squared plus b squared equals c squared. Okay? What is 4? What does the 4 represent? Which letter?
C.
C. Okay, you know that because that's the hypotenuse. Now this one can be A or it can be B. It doesn't make any difference. So I'm just going to say that this is A, and I'm going to say that's B. It doesn't matter, okay? So what I'm going to do is I'm just going to bring down the A squared, and then the B is going to be square root of 2 squared, and then the C is going to be 4 squared like that. The thing on this is you don't want to just know A squared plus B squared equals C squared. That is not good enough. You want to think, okay, that's the hypotenuse. That's the biggest side. That's the longest side. The other two are the legs. So that way you get everything put together. Okay, now let's see what we know on this then. Okay, here it is again. This will keep showing up in this class in higher math. If you square a square root, what happens? It goes away, okay? The square root of anything squared is itself. So that's plus 2. Okay, this is now equal to 16. And then you've got to isolate a squared. So what you're going to do is subtract 2 from both sides. And then that would give a squared is equal to 14. Okay, now what? Square root both sides, good. Okay, so if you have that, you have a is equal to the square root of 14. Now there's two things on this. We've learned how to simplify radicals. So if you were looking at a 14, if you did a factor tree on 14, it would be pretty boring. It would just be 2 times 7. There's not 2 of something, right? So that tells you that that's simplified. If it wasn't simplified, you'd have to simplify that. So what we could do is you just write the answer like that, and if I wanted you to get the decimal answer, you can. So if you do the square root of 14, you're going to end up with some decimals, and then we could round that to like 2 or 3 decimals or whatever. So that's approximately 3.74. So generally in that situation, usually I just either want a simplified radical, like that, that's an answer, that's the exact answer, or like an approximate answer like that. That's it. Okay, everybody with me there? Okay, usually students thrive through these problems. I hope that's still the same. Okay, go ahead and do 15, 16. When you're done with 16, go ahead and go down and read number 17 and start thinking about how you could set that up. Okay? And let's see, this one, the 15 is on the slanted side like that. So just find the missing side. Okay, and you can use a calculator and get a decimal answer if you have to. Or a simplified radical answer, either one.
Since they're both square roots, I just combine like terms.
What's that?
Since they're both like terms, since they're both squared.
Yeah, you're going to have 10 squared plus 11 squared. Absolutely,
Absolutely.
because they're numbers. You'll have 100 plus 121, right?
Do I have to square root or do I then?
Now you got to get them all combined, then do the square root of both sides. Okay?
That's exactly what I'm thinking.
Okay, that's important too. Get everything. You're always going to end up with something squared equals a number. Okay, then that's when you're going to do square root of both sides. What's that?
So since there's no like even numbers or odd numbers.
Okay, if you end up with 221, then you can do the square root of that. Okay, and just use a decimal if you want to. Okay. And then 221, that may even be a prime number. I don't know. I think it is. Sometimes when the numbers get big, it's a little hard to tell if they're prime, but it doesn't divide by anything like 2 or 5 or 9 or 3 or any of the basic things. So in that case, you can just use a calculator and just round to maybe 2 decimals or something like that, and that's okay. Okay, what are you finding on number 15? You're finding the hypotenuse, C, right? Okay, so it doesn't matter what order you do that in, so it's a squared plus b squared equals c squared. Now, a and b are interchangeable. It doesn't matter which is which, so I'm just going to use 10 for a and 11 for b equals c squared like that. So 10 times 10 is 100. 11 times 11 is 121. That's equal to c squared. Then when you add those together, you're going to get 221 is equal c to the second, right? Then what you do is you just do the square root of both sides. Okay? All right? I got that on tape now, okay? Also got the dead spider, right? We did on that when she smashed the spider in the last class, okay? All right. So what we do on this now is we just go square root of 221. And again, if it doesn't turn out to be a whole number, you either want to simplify the radical or you just want to round it off. So this one we'll just say c is approximately equal to 14.87. Like on a test, I usually would tell you, round it off to this many decimals. Okay, everybody got that? Okay. Now on number 16, are you finding, or what are you finding? Either A or B. You're finding a leg, exactly. So you can call that A or B, it doesn't matter, okay? So if you had a squared plus b squared equals c squared, you're going to have a squared plus that leg, 9 squared, equals the hypotenuse squared like that. So that's the setup. So you'd have a squared plus 81 equals 225. Now you would subtract 81 from both sides. So you'd have a squared equals 225 minus 81. So let's see, that's 4, what is that? 1 what?
144.
Yeah, that's right, 144, okay? All right, now you square root that. Now that is 12, okay? If you didn't know that, if you did the squared on your calculator, you would get a equals 12, okay? All right, so whenever these numbers turn out to be whole numbers, if they're all whole numbers, we call that a Pythagorean triple. If you're going to take trigonometry in a future semester, you actually work a whole lot with right triangles. In the Pythagorean Theorem, you do it like crazy in trigonometry, okay? All right, let me do these two applications here. That'll finish us up, and then we're going to get into the 7.7 a little bit here. So these are just, some problems where you're applying it in some context. So this one basically says that you have a volleyball net in the backyard. One of the poles forms a right angle with the ground is 7 feet high. Okay, so that's like the pole. Okay, and for what we're doing, that pole has to be a right angle. So that's what that is. Okay, and then it says to secure the pole, he attached a rope from the top of the pole to a stake on the ground like that. So that's supporting that, so that's making a right triangle. Okay, then it says to secure the pole, he attached a rope from the top to a stake 12 feet from the bottom of the pole. Okay, so let me see, that must be, now we're finding the length of the rope. Okay, so that's our unknown. That's the 12 feet. Sometimes on a word problem, you have to read it a couple of times to really be clear on what it's asking. So it's telling you the height of the pole is 7, and then when you stake that to the ground, that's 12 feet from there. Okay, so what are you trying to find in this? The hypotenuse. You're trying to find C. Good. So that's going to be C. So all we should have to do on this is just C squared equals A squared plus B squared. So that's going to be C squared equals 12 squared plus 7 squared. So that's C squared equals 144. Now I'm going to put feet squared there. Because I want to show you something about units. Okay, so if you square a foot times foot is foot squared, and then 7 feet squared is going to give you 49 feet squared like that. Okay, I'm just going to do this. You don't have to do this when you're working problems, but it's kind of nice to show students this. So now if I add those two numbers together, okay, that's going to give, 193 it looks like. Okay, so that's 193 feet squared. Okay, sometimes units help students understand the concept of like terms. Okay, feet and feet are like terms, aren't they? They're the same thing. You can add a foot to a foot. You can't add a foot to an inch. So what you do now is you take the square root of both sides, and then, yeah, you'd have to go to your calculator on this one. I want a decimal, so we're just going to do square root of 193, and then round that off. Let's just round it maybe to, it says the 10th. The 10th means 1 decimal, so that's going to be 13.9. What do you think the square root of a foot squared is? Okay, see, the math all works. I mean, the length of that rope is in feet. It's not in feet squared. Okay, so it works like that. That's your answer. Okay? All right, any questions about that? Okay. All right, the next problem. I think this next problem is kind of cool. Okay, so a lot of times, like at a car dealership, they have a big balloon because there's a big sale or something. So what it's saying is they stake this rope down, and there's a kind of a constant wind, so it's kind of at an angle, and it's up a certain distance like that. So what it's saying on this is, it says that the balloon is directly above a flagpole that is 70 feet from where the rope is staked. Okay, so that means this piece right here is going to be 70 feet. Okay, then it says find the altitude of the balloon if the rope is 90 feet long. So an altitude just means how high is this thing. So we're going to be trying to find that thing right there. Okay, so technically if you knew how long the rope was, and if you kind of could ballpark figure out how far that rope is on the ground to looking straight up, you could tell how high the balloon is. So that's kind of cool. All right, so what are you finding, a hypotenuse or a leg? A leg. So let's call that A or B. So we'd have A squared plus B squared equals C squared. So I'm going to say A squared, leave it alone. Then I'm going to do the 70 squared, which is the other leg. That's equal to the hypotenuse, which is 90 squared like that. Okay, so that's the setup. You need to go ahead and square everything. So that's A squared equals 4,900. 90 squared is 8,100 like that. Okay, use your calculator if you need to. Now I need to subtract 4,900 from both sides. Okay, we're probably going to have to get the calculator out at the end of this problem anyway, just to get a decimal approximation, maybe. Okay, so let's see what we have here. So 8,100 minus 4,900. I'm being lazy. What's 81 minus 49? Okay, so I'm just lazy today. So 3,200. Okay, now we do the square root of both sides, and then we can just go to the calculator on that. Okay, this kind of problem, I'm just going to get a calculator answer. Okay, so that is 3,200, and that would give approximately 56 point, let's just round to 1 decimal, approximately 56.6 feet like that. That's it. Okay. Okay, you guys got Pythagorean Theorem under control. Students almost always do, okay, at this level of a class, okay? This is just something that students tend to do well on, I find. Okay.